Okay, so we have today and we have Thursday to go over material. And on Thursday, I'll tell you what's on the quiz. I'm not giving you a practice version. I'm just gonna tell you what's on it, question for question. And then you'll take the quiz ideally next Tuesday. For those of you who are gonna be gone, take it Thursday. Figure out sometime next week to finish it. So anyway, what else we need to know before we start? It is very humid and my ears are very stopped up, so if I don't hear something, please give my attention. But let's go through lecture number 50. We jumped a little bit. I jumped over some statistics topics. We did arithmetic and geometric. I skipped over like permutations, combinations, some of those topics. You'll get those in statistics class if you take it. If you don't, hopefully you've already had it. Excuse me. We're going to jump into limits. Okay. So real quickly, limits is kind of in calculus. There are three main topics. Number one is limits. So I'm going to introduce you to the very first calculus topic. Yes.
It's kind of cold in here.
Is it cold?
Yeah.
I am not.
It's always cold in here.
I think the air is blowing up into the air, but
I'm not.
I
Like,
feel very comfortable.
I'm not like one who complains about it, but I just noticed it.
Was it colder when you just moved up to the front?
A little bit.
Because the air might be hitting you a little bit. Okay, so there's three main topics. Number one is limits. We're going to give you a slight, very slight introduction. This is going to take us, in calculus, it usually takes us 3 to 4 weeks to get through all the different topics of limits. Okay, so we'll talk about this, the basics. And then number two, the next one is derivatives. Derivatives are based on and solved by using limits. You can't do derivatives until you know what a limit is. Okay. And then number three, integration, which is undoing derivatives. So in calculus class, those of you taking that next year, we'll spend probably a month on limits, then we'll spend the rest of first semester on derivatives and their applications. And then we'll spend probably February, March, April on integration and its applications, and then be done next year. So that's kind of the way it breaks down. Okay. But we sort of want to touch on this basic idea of what exactly is a limit. What exactly is that concept? So let's first of all talk about, number one, kind of a definition. And this is more of a definition of calculus. Some people ask what exactly is calculus. Very simply, it's the study of motion. Or we're going to call it a rate of change. Now from Algebra 1, what was the rate of change? There's a 5-letter word that we do all the time in Algebra 1.
Slope.
Slope. So study of motion is the rate of change, how it's changing from place to place. Okay, using tools that measure static items. So in Algebra 1, we said, what's the slope between 2 points? Well, that's kind of a static. It's been saying it's standing still. Like, we take average distance. Well, from one point to another. Okay, if we go from Kansas City to St. Louis, which is 240 miles. It's actually about 247 from state line to state line on I-70.
Seriously? That's
Yes. So we'll go with 240 as a round number. And we drive in 6 hours. What was our average rate of change? 240 miles in 6 hours.
40.
About 40 hours, about 40 miles per hour. About 40 miles per hour. Well, those are static things. Those are like we're standing still. When we start and we end, and then we have this set number. Okay. Well, what about when the car is in motion? Were you always doing 40 miles across St. Louis? No. You're driving I-70. What happens? Traffic jams. You speed up. You get behind a semi and you're doing 90. I mean, doing 65 the speed limit.
And
Always do the speed limit. go up to 65, and then you stop for gas, or you stop to get something to eat.
Stoplights.
Say it again.
I said red lights.
Red
It's a
lights,
highway.
not on the interstate. But good thought. If you're going through town, maybe through a stoplight. But you're gonna have all those things that are gonna slow you down in the speech. But so at any point in time, you're going either 70 miles an hour, or maybe you're going 30 miles an hour, or in your traffic jam, you're doing 10 miles an hour, or through a construction zone. So your speed is gonna be going up and down and up and down, up and down. But our average is 40. Calculus helps us study those movements up and down. Okay, and limits is a big part of that. So, our first problem. I don't have my glasses. Let's examine, yeah, sort of sucks, doesn't it? Okay, let's examine this particular function. Who was that?
Instantly points at me.
What'd you say? Huh. Do you have it turned off now? Okay, so let's examine a function. F of x equals x squared minus 4 over x minus 2. Okay, let's look at that function, nice rational function. So the first thing you ask yourself is, where is the problem? Or where is the issue? So look at this particular problem and where do we have an issue at? In fact, we had a teacher who used to call these no-nos.
What's it called? The denominator.
Denominator. And what value in the denominator causes the problem?
X.
Say again?
0.
No.
2.
X.
2.
Oh boy.
Because if x equals 2, my denominator is 2 minus 2, which equals 0, and I can't have 0 in the denominator.
Yeah.
Right? So x equals 2 is my location. X equals 2 is my problem. Okay? But look at the top. What if I put 2 into the top as well? 2 squared minus 4. What is 2 squared minus 4? Which is 0. So we have this unique solution, 0 divided by 0. Now normally, we can't divide by 0, correct? You can't take 7 and divide it by 0. But when I have 0 divided by 0, this is what we call indeterminate form. Indeterminate, unable to be determined. We gotta do something else. Okay, this is called indeterminate form. So whenever we get 0 over 0, we can look at this from the from the perspective of a limit. What does the limit tell us about it? Okay. So let's take this particular function, and there's 3 ways we look at limits. One of them is algebraic. We'll talk about that one later. One of them is tabular, which we're going to look at now. The third one is graphic. We'll look at that here in a second as well. So let's look at this from a table. Let's look at what is this value approaching. Okay? So y'all have calculators? Have a calculator? Okay. Someone should have got that for you. Come on, gentlemen. Make her get up on crutches, really?
I think I was really.
Thank you, Marty, for being gentlemen and helping. Jalen, I expect more from you.
I forget.
I forget.
How you forget 2 big old pictures?
She was.
Yeah, right, the big old crutch sitting right there.
I was one.
Okay, so we know I made a little chart here with 3 points on either side of my middle point. My middle point is my issue. My middle point 2 is 0 over 0. That causes my problem. Okay. So let's look just to the left of 2, and let's look just to the right of 2. So, and we're gonna get really, really close to the value of 2. So let's look at like 1.9 and 1.99. And even closer, 1.999. Let's look at those values, okay? Now take your calculator, plug those values into the function, and see what values we get. So 1.9 squared minus 4 divided by 1.9 minus 2. See what you get. 3.9 for 1.9?
Yeah.
3.9? Okay, what about if we put in 1.99?
Negative.
I think it's the same thing.
Minus two?
Oh, it's just 3.99.
Oh, times
3 point-
four?
It just keeps on going.
What'd you say?
My bad, I was on the bottom. We're doing the top, right?
Yep,
Yeah, it just keeps on going.
3.99.
And
And where do you suppose the next one's gonna be?
3.98.
3.999.
Yeah.
So what's happening, as we get closer and closer to 2, what does this value look like it's getting closer to?
Zero.
Looks like it's getting closer to 4. But how do we know it's not 3.9999997? How do I know it's not 3.9999923? I really don't know those at this point. But intuitively, it kind of looks like it's approaching 4. Let's try the other side. Let's come here and let's go 2.1. 2.11, I'm sorry, that's not closer. 2.01 and 2.001. Let's try those values. So start at plugging 2.1 into my function. And then plug in 2.01.
Negative 1.8.
What'd you say?
Negative 1.8.
Nope.
No.
4.1.
What'd you say?
I got 4.44.
4.44? That's not what I got. Try it again.
2.
What's on the bottom of the middle one?
I can hear you.
What's on the bottom of the middle one?
0 divided by 0.
4.1.
4.1. There you go. 4.1.
Calculator mistake.
So
Yes.
then the next one, would it be 4.0?
Oh.
I don't know. Is it?
4.11.
I don't know.
Is it 4.01?
Wait, no, it's 4.01.
I'm guessing, I'm guessing.
Check it to make sure. Check it to make sure.
Oh.
So this one gets smaller.
I'm getting closer to 2. So here I'm coming from the left. Here I'm coming from the right, getting closer to 2. What's this value getting closer to?
0. Oh, well, it's getting closer to
So
Yeah,
Four.
it's 4.01.
4.01?
it's
What's this one probably going to be then?
4.001.
4.00.
What are you putting in the calculator?
put it, what's it called? Brackets.
So you're plugging in those numbers, the top numbers, you're plugging them in for X. And like doing the formula with those.
Just plug and chug.
And then when you divide it, put it in brackets, like the
Yeah, so, cause
4.1 minus 2.
Oh, so you're doing the top and then doing it by the bottom at the same time? Like in the equation? Oh, okay.
Okay, so look up here then. This one looks like it's, as we're getting closer to 2, looks like it's approaching a value of 4. As this one is approaching a value of 2, it looks like it's getting closer and closer to a value of 4. So we could intuitively say that at 2, the value is 4. Okay. Now we don't know that for sure, okay, but we get the idea. So when it comes to table, this is just more of an investigation. This is more of a, this looks like what's happening, but we're not for sure yet. Okay. But we could kind of say, it looks like it's getting closer, and it is, getting closer and closer to that value of 4. Okay. So here's how we write it. I'm going to erase this top part, I hope that's okay. I want us to get the notation and see what it looks like. So what you've just done is, let's go to green. So what you've just done is you said the limit, LIM, as x approaches, and what did x approach?
4 or 2.
X approaches 2, as x getting closer and closer to 2, then the function x squared minus 4 over x minus 2 was approaching what value?
4.
It's approaching a value of 4. It's getting closer and closer and closer to 4. So and honestly with limits, I don't actually care what happens when I get there. Because when I get to 2, does the value even exist?
It's indeterminate.
Yeah, it doesn't even exist at x equals 2. Okay, it's a no-no, we've done that for years. X can't be 2. But now I can say, as I'm approaching 2, I'm getting closer and closer and closer to the value of 4. And that's what that means, the limit as x approaches 2 equals 4. Okay. And this is an extremely powerful concept. When you get to calculus, it actually gets really, really cool the further we go. Okay? So, by definition, kind of notation by definition, we could say that the limit as x approaches a of some function is going to equal L even if a does, even if a, is not defined I'm sorry, that didn't sound right when I wrote it and I still looked at my notes. Even if f of x is not defined at a. Like in our last example, it's not defined at a, it's undefined. It's indeterminate, it's a 0, you can't do that. But even if that's the case, we can still find the value that it's approaching from the right hand and from the left hand. I draw this example in calculus, you'll see as we go. We have this function, and I don't care what actually occurs at this point. Let's just say this is A. I don't care what's happening at that point. What I'm concerned with is what value am I approaching from the left and from the right. When I get there, it doesn't really matter. It doesn't really matter that 2 makes it 0, 0. The fact is, as I'm coming closer to that point, I'm coming closer to a value of 4. So I don't really care about that actual point.
So that's how you would like graph it?
No, this is not how I graph it, but this is an example of what I'm doing. This really isn't how I graph that function.
Not that function, but like if you're doing the work, like on a problem, that's
Well, you'd
how-
have to graph the actual function. To graph what it actually is. Okay. All right. So let's do another example. And this is actually going to make this first process, you better not miss this. This is the easiest thing in the world. Okay. So we're going to go with, what are we on, number 2? Number 2. Find the limit using a table. And let's give you f of x equals 3. Well, actually, let me write it as a limit. Hang on. The limit as x approaches 4 of 3 times x squared. All right, so let's take this half of the room, you guys, let's approach it from the left-hand side. So you guys find, let's find, let's see, 3.9, 3.99, 3.999. You two do that one. This half, the east half, you guys over here, let's do it from the other direction. Let's see what I did in my notes. 4.1, 4.01, 4.001. Okay? So you plug in the 4s, you plug in the 3s, and let's see what value I actually get here. 1x is 3. I'm sorry, 1x is actually
Do you want us to start at 3.9?
No, you guys are starting at 4.1.
You just have to, this side over here.
Okay.
You guys do 3.9, 3.99.
You read the answer under it, right?
So what? Yeah. Do you have an answer for 3.9?
45.6.
Say again?
I said 45.6. Is that wrong?
That's not what I got.
3 times this 3.9 squared.
Yeah, yeah, cause every time we put it in the calculator, it goes through 45.63. It doesn't, what? 'Cause
Well,
then-
let's see, because 3 squared is like 9 times 3, it's 27, so I feel like it's not too far.
Yeah. But I think what the calculator is doing is taking 3 times 3.9 and
Well, I put brackets, let me see.
I did too.
3.9 squared.
And it's putting the squared on the outside of the 3.9.
I'm getting 45.63. Is that what you got?
Yeah.
Okay, 45.63.
So if it's 45.66.
Nope.
6.3.
Okay, maybe. Wait, why is it a different number?
What'd you get?
47.8.
47.8, okay.
47.7603.
And what's 3.999?
48.
47 point something?
It's just 48.
3.999 squared. Your calculator's rounding.
Squared.
It's 47.976.
Yeah, my calculator doesn't do that.
Yeah, your calculator's rounding. So 47.97. Okay? Alright, so what'd you guys get when you plugged in 4.1?
50.43.
You know what?
50.43.
50.43. Okay, what about when you put 4.01?
48.24.
48.24?
Bum,
And what about when we put in 2 zeros there?
48.02.
48.02. Okay? So, if I come from the left-hand side, if I'm coming from 3.9 to 3.99 and getting bigger, what value is it approaching? Because
48.
it's approaching 48. It's getting closer and closer to 48. In fact, I would dare say if I put in 3.999, I would have like 47.999 something. Okay. What value am I approaching from this side?
48.
50 to 48.2 to 48.0. So it looks like I'm approaching a value of 48. And this brings me to my first step. Step 1, solving limits. It's what you always do first. And it's called direct substitution. See, in the last example, we had a no-no. We had a place where it didn't exist. We had x equals 2 made 0 over 0, right? What if I just plug 4 directly in here? What if I just do 3 times 4 squared? Notice what I get.
48.
I get
That's
48.
just 48.
4 squared is 16 times 3. I get the limit. So the first thing we do is, and the reason becomes 3x squared, there is no problem. There's no no-no. There's no indeterminate. It's just directly plug it in. If you plug it in and you get a value, that's your answer.
Okay, so we don't need to do box stuff.
Not if there's no problem on the first type. Okay? So like for instance, if I give you the limit as x approaches 2 of 3x plus 1, is there any no-no there?
No.
No, it's just a linear problem, right? Just plug 2 in. What do you get?
6, 7.
My answer is just plug it in. It's the answer 7. Easiest thing in the
So
world.
7
Plug
is a
it.
denominator, right?
Say it again.
7 is a denominator?
There is no denominator. The answer is 7.
Okay.
Think about 3x plus 1. What's the graph look like?
3 up.
Start at 1,
Well, actually, no. It's
up 3 over 1. Looks something like this, right?
Yeah.
So as I come and approach from the left-hand side, x equals 2, there's x equals 2, what value is it approaching? What value am I approaching? Well, there's no problem, it's just 7.
2, whatever. Oh, it's just 7.
It's just 7, you just plug it in, you get your answer. Because that's what value this function is approaching. There's no no-no, there's no breaks, there's nothing wrong with this particular graph.
Wouldn't it be an x and y value though?
Well, this is your x value, because as x approaches 2, and then your y value is the 7. So it's 2, 7.
Okay, okay. Here you go.
But this is gonna be your x value. Okay, so direct substitution, you just plug it in. That's what you always do. But what if it does become 0 over 0? That becomes a problem. That's where I have to come into, and there's all the other forms as well. But that's where I have to do something different, like the table, or some other method of solving it. Okay. Let's try another example. What if I give you the limit as x approaches 0 of sine of x over x? Okay? So the first thing I'm going to do is directly substitute. Okay? Let's plug in 0. Let's see if that's going to work. Okay?
It
So
will
this is
not
going to equal the sine of 0 over 0. What is the sine of 0?
1.
0.
0.
Oh, so
Cosine of 0 is 1. Sine of 0 is 0 over 0, indeterminate form. Okay? So I got 0 over 0. So now you have to do something different. Okay? So, what values will I put in? Let's do this using a table. What values will we put in?
2 get to 0. 2 and 1.
So here I know I get x equals 0, I get 0 over 0. So what values am I going to come from the left-hand side?
0.9.
0.9. Oh wait a minute, that's
On the right.
that's bigger than 0.
So that's on the right.
Negative 1.
Okay, I would put negative 0.1, negative 0.01,
Negative 0.00.
negative 0.001. On the other side, what values should we put?
0.001.
I mean, you could just do.
Yeah.
0.01, 0.1.
Yeah, because 0.1's the biggest.
Uh-huh. And see what value am I approaching from the left or from the right.
Yeah.
And honestly, when you do this, you probably only need to do 2 or 3. You know, 2 on this side, maybe 1 or 2 on this side. Okay. If you want to do all 3, it kind of gives a bigger picture. So plug them in and see what you get. Make sure you're in radians.
Really?
Yeah, make sure you're in radians.
I keep
But
on
real
getting the same
quick-
answer.
What'd you say?
So I keep on getting the same answer.
What'd you say?
Real quick, wouldn't it just like cancel everything and be signed?
You can have a sign without something.
Oh.
You have to take the sign, you don't just have sign, you have sign of
Sign.
30 or whatever. Yours is probably because it's not, it's rounding too quickly. Grab a blue calculator here, try this one. Oh, so
Wow.
close.
Bumbled that.
Unfortunately.
Did anybody get the sign of -1 divided by 0.1 divided by -0.1?
Let me see right now. Let me see.
What'd you get?
I got the same exact answer
Yep.
for going.
Should be at
that one.
0.9983.
Oh.
0.9983.
It's just syntax error. It's just in, how do I change it to degrees?
Is it document settings?
Wait, what time is it? And YouTube is human nurse.
What's wrong with your calculator? Did it die?
Yeah.
Already? I gotta get new calculators.
How do I, it's just syntax error.
Let me see.
How do I get out of it?
Or did it just do it?
You're in degrees.
Do I just press my default or Sora?
Oh,
Then you divide it by- So it's this.
Why
Oh.
did you do it? Cause I was
Here's
thinking.
the problem. This number in here, you hit negative, it
me
should
too, I'll
hit
go.
negative.
Oh.
Well, those are
Okay,
two different
okay,
ones.
okay, I see, okay.
Mm.
What was it?
So do we get negative 0.01?
Oh, yeah, well, yeah.
What'd you get?
Negative.
Should be a positive.
0.017. Oh. 0.017.
No. Are you in radians?
Probably. I don't know how to change it, but you know it.
Just go to.
I don't know how to change
How long have you been in my classroom? For 2 years, you should know how to change it. Go to menu. Go to home screen.
Yeah.
Change language.
No, do not change the language. Document settings.
So 4.9. So I got 9.9.
I keep on getting the same answer.
9.
Here we go.
And 4.9.
I should be in radians, you said?
Uh-huh. What'd you get, Savannah?
0.99998.
Yeah, I mean, I got the same thing.
That's correct.
Yay.
Oh, it's just an extra 9, okay.
2 nines, 2 extra nines actually.
Yeah. 2 extra nines.
Yeah, it's 99998.
What do you suppose the next one's gonna be?
0.9999983.
Correct.
Wait, really?
So it
Yep.
goes up
Oh,
to
let's
2,
go.
right?
And of course it continues.
So the closer we get to 1.
So what's it look like we're approaching?
1.
Sure looks that way.
Yeah.
Let's go.
Let's try the other side.
0.1.
Now, honestly, think about this for just a second. Okay, pause for just a second.
It's the same
Wait.
thing.
Why is it gonna be the same things?
Because we're the same number.
Cause what?
We're the same number.
They're the
just-
same
Positive,
numbers.
negative, yeah.
It's just you change the signs.
Yeah.
So if rather you go from a negative and negative to a positive positive, you can end up with 0.9999983, 0.9999983, 0.99983, 83.
But you just make them negative, right? Oh, so it's just a single.
Just
step.
switch sides.
Fine.
So then we're approaching the value of what?
No.
Fun.
Wait, no.
Sure looks like we're approaching the value of
Yeah.
what?
So when, as we approach 0,
So the limit as x approaches 0, it looks like this is going to equal 1.
okay.
Oops, eraser. So it looks like some of us need to work on a calculator and how to use calculator, how to punch it in. But do you get the idea of plugging those numbers in?
Yes,
Yeah.
sir.
You're getting closer and closer to a value. Second way to look at it, this is tabular, right? This is using a table. Second way to look at it.
Is that actually like pure, like true English? Like if you say like using a table, it's to tabulate? No.
It's math English. It's, oh.
Oh, doesn't have it on this one. Yes, it is tabular. This one says numerical. My other calculus book says tabular. Okay, so let's look at a different way of looking at it. This one you'll like much more.
I don't
Choose
know.
Desmond's.
Oh.
Okay. The one we just did, the sine of x over x, right? Let's take a look at it. As I'm coming from the left-hand side, it looks like it's approaching a value of 1. As I come from the right-hand side, it looks like I'm approaching a value of 1. In fact, I think I put my, right there. You can kind of see and follow it. It looks like it's 0.906, 0.94, 95, 96, 97, 98, 99,
1.
and then nothing. When you get to
Undefined.
0, you get undefined.
Wow.
And then as you go to the other side, 0.99, 0.98, 76, 32, 74. So we see it's completely undefined there, but we can see it sure looks like it's approaching 1. But could it be approaching 0.9999999999992? Could be. We haven't exactly proven, but we've intuitively figured out it's getting closer and closer to that value.
Wait, so why do we say 1 then?
Say what?
So why do we say 1 then?
What do you mean, why do we say 1?
Because that's just what it looks
Instead
like.
of 0.999999992.
It looks like it's approaching 1. We're just not for sure. We have to do it algebraically to get it for sure.
Okay.
Back to this one, the same thing is true. F of x equals x squared minus 4 over x. This is our first example. You can see it looks like a linear equation. As x gets closer to 2, though, you can see it's getting closer, 3, 7, 3, 8, 3, 9, but then it's undefined.
Oh, there's a hole.
There's a hole there. Yep. And decimals will show us the hole, but you have to go looking for it. Okay? Now on Thursday, we're going to talk about, okay, what about, how do I find it algebraically? How do I know, not just intuitively, but how do I know for a fact? That'll be on Tuesday. And
You're
of course,
gonna record that, right?
calculus as well. On Thursday, I mean, I'll be on Thursday. You'll be here Thursday, won't you?
No, we're
Yes, I'll
meeting
record
at
it.
3 in the morning.
Yes, I'll record it for you.
Thank you.
Yep. Okay, so we got the idea of table, and you can also do it graphically. Okay, let's look at the idea of graphically, and then kind of build on ours a little bit. Roman numeral 3. What about from a graph? All right, you have to sketch a few graphs here with me. So go ahead and make a XY axis. Make it out to maybe 4 on each axis. So 1, 2, 3, 4. 1, 2, 3, 4. Okay. Okay, you got that made? Okay, so put a point at -4, 0. You got that one?
Yeah.
Okay. Put an open circle at -2, 2. And then connect that with a curve. Something like that. circle at 1, -1. And then connect those two open circles.
Wait, it's not a curve?
No, the second one's not a curve. So this should be a curve here. It's not really a big deal for this example, but that's what line looks like. Straight line between those two. Make a solid dot at 1, 1. At 4, 1, make an open circle
It looks like a scythe.
and connect them.
Oh.
Now, what type of function do we call this?
Scythe function.
Site function?
Scythe.
Site.
Oh, I see what you're
No.
talking about.
Good thought, but no.
Okay.
That's you were saying site, like a SIGHT.
No.
You're saying.
No, like the Grim Reaper?
Gotcha. Took me a second, okay.
Alright, 1.
So what type of function is this?
Logarithm.
Not logarithmic.
Disjunction, I don't know.
Starts with a P. Piecewise.
Yeah, we weren't gonna get that.
Piecewise function. And what it means is it's in pieces. We have a curved spot here. This is actually gonna be a quarter circle. We have a linear and we have a constant. 3 different parts. It ends at -4 and it also ends at 4. In fact, I'm gonna put a solid dot right there. Let's make that a solid dot. So it ends at 2 places. Okay. Ends at -4 and +4.
Should put that on the exam to see how many people paid attention. What kind of function is
What kind of function is that?
As a piecewise, yeah. I know.
Okay, now, let's take this and let's find some limits, okay? Let's change colors so we can see it in different colors. Let's go with A. Let's find the limit, and I'm just gonna put f of x. That's gonna represent the whole function, okay? We'll call this whole thing f of x. Let's find the limit as x approaches -2. Okay. So what I'm looking for is, what is the y value as we approach x equals -2? So here's x equals -2, right? So my function is going along here. What y value is it getting closer to? What's the y value?
It's not 1.
2.
2, getting closer to y equals 2. What about from this direction? What y value is it approaching? 2. What happens when I actually get to 2? What is the value at 2? If I were to say 2, what's the y value? Say it again.
Undefined.
Undefined. Because it's open, right? So there is no value, I should say, at x equals -2. It's just the -2 there. Okay? It's totally undefined. There's a hole there. Does that matter? Does it matter that there's a hole when I actually get to -2?
No.
The answer is no. All I'm caring about is what value am I approaching from the right and from the left. And they're both approaching the same number, so the answer is +2, the y value.
Positive?
So does the negative not matter? Or
What do you mean the negative?
what's it called? Oh, because it's just approaching y2, right?
Correct. X is -2.
Yeah.
It's approaching y as a +2.
Oh.
Let's try another one. Let's try the limit of f of x as x approaches 1. Let's look at as x approaches a value of 1. Okay? Let's come from the left side first.
1.
What value is this approaching as I get closer and closer to x equals 1? It's approaching a value of what?
Negative.
Approaching a value of -1, right?
Wait, how do we know we're starting from, like, which function?
Okay, so I just said, let's just start from the left.
Okay.
Okay. Now let's look at the right. What value is it approaching from the right?
Same thing, 1.
It's approaching a +1, right? So from the left, it's approaching a value of -1. From the right, it's approaching a value of 1. Is -1 and 1 the same?
No.
No. So this limit does not exist. They have to be approaching the same value. They have to be heading to the same point. If they're not, there's no limit. It doesn't exist. So to answer your question a little more thoroughly, Jalen, we actually can have, and this is the point in the discussion where I introduced to you one-sided limits. Okay. In fact, that's next in my notes. Let's look at this concept of one-sided limits. What do you suppose a one-sided limit would be?
A one-sided function.
No?
Only comes from one side.
I'm only coming from one side.
Well, yeah.
The limit is I'm coming from both sides. One side, I'm just coming from one side. Okay, so let's go back and look at the value of 1 again, okay? I don't like this red. Do you guys like the red? Can you see that okay?
Yeah.
Okay, all right. So let's try this one. Example, the limit as x approaches 1, but then where the exponent goes, I'm gonna write a little sign, okay? So I'm gonna write 1 from the negative side. That little notation where the exponent is, that means I wanna come from the negative side, okay, of f of x. So what that's looking at is, okay, it's coming from this direction. It's coming from the negative side of the function. What value is it approaching?
-1.
-1. Okay, let's change colors. And let's look at the limit as x approaches 1. But now I want to come from the other side, the positive side. So now I'm looking at this direction. What value am I approaching as I come back towards the value from the positive side? And that's going to be equal to 1.
So does that mean you're never gonna get, like, no answer?
You're never going to get what?
Like, no answer?
Yes. Because in order to have a limit, your right hand and your left hand have to be equal. If they're not equal, so while I have the left hand is -1 and the right hand is +1, the limit of f of x as x approaches 1 does not exist. Because those two are not equal. So you can't just have a one-sided limit, yes?
Can I ask a question?
Yep,
So they have to be equal to have a limit?
correct. The right side must equal the left side.
Like, is that just in a graph or
So,
also like
like-
an equation too?
Always.
Okay.
Is it only piecewise functions?
I wanna make sure, you know.
Say it again?
I said, is it only with piecewise functions or?
All. Piecewise is where we're gonna see it the most happen. Okay, there's not a lot of functions, we'll see some, but most of the time it's gonna be a piecewise. Okay, one more, see if you can figure this one out. This is a little bit of a challenge for you. Now that we looked at one-sided limits, do one-sided limits make sense?
Yeah.
You just look at one side or the other? Yes? What about the limit as x approaches 4 of f of x? So here's 4, right?
Yeah.
Yeah, what
It's
did it
approaching
just
from the left-hand side, what value? y equals, okay. What about from the right hand side? Is there anything over here?
Oh, it's not coming.
There's nothing there, right? Because 4 is the endpoint, correct?
Yeah.
So you only check one side.
Okay.
Because this is the same thing as the limit as x approaches 4 to the negative. On endpoints, there is only one side.
So wait, so that's one instead of nothing?
Correct.
That's interesting.
It's an endpoint.
Okay.
So there is no, this is outside of its domain, so you don't have to look at it. You only look at what
So
you
is it
have.
just saying that you don't know?
You say what?
I'm saying, is it just saying that you don't know, or, cause like you had to do, a one-sided limit for one, but this one, you just do one side.
Because there is only one side.
Yeah.
Here, you can approach from both directions. Here, you can't, because it's outside its domain.
I see this.
So you just look at the one side equals the limit. That one's usually a little bit of a tricky one. We do some trick questions there. Okay, one more. Let's put two things together, piecewise, and what was the very first thing for limits we always do? Very first thing, step one. Step one is direct substitution, just plug it in, okay? Let's put piecewise with direct substitution. Okay, let's try this last example. Order on Roman numeral 4.
We just did 4,
We did 4.
yeah, we were on 4.
Okay, 5. Piecewise. If you don't remember piecewise or you've never covered them, here's what it's going to look like. It's going to look like f of x equals, then you have a French braid,
Oh, okay.
and you're going to have 2x minus 4 is one piece of it. For x does not equal 3. And then you'll have another one, negative 5, for when x equals 3. It's going to look something like that. We may have greater than, less than values in there. Well, it's going to look something like this will be in pieces. Okay. So I'm going to ask you, obviously, to find the limit as x approaches 3 of f of x, because that's where the problem occurs. That's where these two pieces fit together.
Well, we have to graph it.
Is
first,
that 3?
right?
Say again?
That's when we have to graph it first, or?
You don't have to graph this one. Do I care what happens when I actually get to x equals 3? No, I don't. All I care about is as I'm approaching. So what's the first step of limits?
Substitute.
Substitute. So plug it in. 2 times 3. Do I get 0 over 0?
No.
No. What do I get?
1. Or, sorry, 2.
Equals 2. So the value is 2. when you're done.
Oh.
And you really do just plug it in.
Okay, so does that mean that x is 2?
Say it again.
Is it saying that x is 2?
X
Or is it?
is approaching 3. So y is 2.
Y is 2.
Yeah, always look there. X is approaching this value, so that's your y. All right, we'll stop there. We have a few minutes. I do have a homework assignment for you. Some of it's dealing with graphs. Work through them. They do get a little more challenging than what I have up here, but it's on Schoology. So on Thursday, we'll actually answer that question. How do I know for a fact about some of these that we kind of did a table with? How do I know for sure? How do I solve them algebraically? We'll talk about that on Thursday.